So similarity is an area of geometry where we definitely are going to mix some algebraic ideas with some geometric ideas. So similarity is like it sounds. It is a similar figure. So congruence was the exact same figure, just in a new location. Similarity, we are going to do just a single little swoop, and we are still going to have corresponding sides and angles, except everything's going to be blown up or shrunk by a constant proportion. It's going to be called the scale factor, and we'll study that in a couple of sections. So some important terms as we get started. Let's start down here with preimage, and this is the figure before any transformation. Now, a transformation is our broad term for a change. Now, transformation itself means to change, so there's several different kinds of transformations, but basically the preimage is our original. It is our original figure. Now, an image is our figure after a transformation. So what does the figure look like? Where does it land after a transformation? Now, notation is always really important in geometry. Our pre-image figures, we're going to name like we have been. We're going to name vertices with capital letters. Now, because of this corresponding nature, our corresponding image, because we want to see how they match up, is going to be A prime, B prime, C prime. We're going to put that little apostrophe to see that whatever this A was, it got moved and landed to that A prime. If you would happen to move it again, you would have A double prime, B double prime, C double prime. Now, what kinds of transformations do we have? Sorry about that. We have reflections, translations, rotations, and dilations, and we'll talk about each of these during this unit. So a reflection. A reflection is one of our most basic kinds of transformations. We talk about it as a flip. We are going to flip it over some sort of a reflecting line, like line K here. This creates congruent figures. When we do this, we do not change the size or shape. So when you graph it, it should look exactly like the original, just in a new location, a mirror image, if you would like to think about it that way. So if we think about common sense, reflecting, think about folding this figure in half over the red line. Point J is 1 unit away. J prime is going to end up over here. M was 1, 2, 3 units away. 1, 2, 3. M prime is going to end up over here. And K is 1, 2, 3 units away. So I will end up 3 units away over here. K prime is here. And you see this figure that is exactly the same, just reflected across that line. So I can do reflections across random lines, and I simply have to count equidistant on either side of the reflecting lines. Where things get a little bit more interesting is when we start reflecting over some special lines that we have. So the x-axis, so let's be sure we know which one is the x-axis, and so we are thinking about using this as our reflecting line. Now we could use our counting rule just the same. So M is 1 unit away. M prime is going to go 1 unit away. H is 1, 2, 3, 4, 5 units away, so it's going to be 1, 2, 3, 4, 5 units away. And D is 3 units away and 3 units away. Now, we don't always want to have to count these. And so if we look at the coordinates of M, they are at -3, 1. H is at 4, 5, and D is at, -4, 5, and D is at -6, 3. When we go down here and we look at h prime, we are at -4, -5. M prime is at -3, -1. And D prime is at -6, -3. And when you look at that, the only thing that's changing, your x coordinates are all exactly the same, but your y coordinates go from being positive to being negative when you reflect across that y-axis. So in general, we can write a rule that says this transformation of my xy, my preimage, will become t prime, my new one, of leave the x alone and do the opposite sign on the y. If they were negative, they become positive. If they're positive, they become negative. That same logic would apply if we come over here and we look at reflecting over the y-axis. We could go ahead and count 3 units away and know we'll end up 3 units away. And M prime will be right there. And we could go through and we could find all of them. Or we could think about a rule that says what happens to my new figures. So if M was at -3, 1, and M prime goes to 3, 1, we would expect D being at -6 is going to end up over here if I fold in half. D prime is going to be at 6, 3, and -6, 3. And you can begin to see that pattern that this time my y stayed the same, but my x coordinates changed signs. So what I can do is my x is the opposite this time, and my y's stay the same. Does that work for h? H is at -4, 5. So we do the opposite sign, which is +4, same x, and h prime is happily right where we expect it to be. And when we connect those dots, our figure looks just like the original.